In this particular packet tracer, you can see that over here, you can, the first row highlights about the network device categories, and then first one is network devices. Yeah, that's network devices, and then the second is end devices. The third one is components. Then you have connections, and then you have miscellaneous and some multi-cluster or multi-user devices. So if you click on the networking devices, the next row kind of shows you that you have routers, you have switches, you have hubs, you have wireless devices and security devices and WAN emulation devices. So these are all type of the networking devices section. Then second, when you click on any devices, you see over here that the end devices kind of gives you uh, end devices itself, home. Then you see smart city devices, you see industrial devices, and you see power grid devices. Okay, just like that, you can browse through multiple options that are available over here. And when you go on the first devices, that network devices, then you can see that over here by clicking on the router section, you can actually browse through multiple models of the routers that are there. So the first column kind of highlights you with all the devices, and the second column kind of gives you the models that you have over there. Okay, for each and every device that you have. So when you click on the networking device, you can select that you want to see routers, and these are different models of routers that are there. Makes sense? When you click on the networking device and click on switches, you will see different models of switches there. And when you click on the third device, that's kind of hubs. So you will see different models of hub as well. That's how you browse through the list of devices that are available. And then over here, this is kind of a scenario where you can where you can create multiple scenarios of topology, and over here you will see the real-time status of the traffic that you're forwarding. So we will now build a small network over here by just taking a couple of computers, and we will connect them together by using a cable and assign them IP addresses and see how they can communicate with each other. So we will go to the end device section over here, and then we will select the end devices and select PC or laptop. You can select any two of these. So I will, let's say, in order to select PC, you just need to drag it, click it and drag it into the workspace. And then you can drag another PC over here. And then in order to connect them together, you're going to select the connections and select this first cable always, which says automatically choose connection type. This works according to AutoMDIX, I would say. So you select this, then you drag it across without like clicking on it. Just click on it once and then click on the first device, drag it, and click on the second device. That's how you make a connection. You see that the cable is attached now between two PCs. So now let's say that we want to configure IP address on the interfaces of this computer. So what I'll do, I'll just click on the first PC, okay, and you can see that the dialog box appears over here. And then you can go and navigate yourself to desktop, and then you can go to IP configuration. Okay, I'll do it again. I will close it. In order to configure the PC, I will click on the desktop or the PC, and I will select desktop option from the available tabs there. And then from the desktop, I will select IP configuration. And that gives me this particular window in which I can configure IP addresses both by static and DHCP. As of now, we will just move ahead and configure a static IP address. And then let's keep that particular IP address of a class C. And we will also add a note over here so that we remind. So I'll just take a note utility. I'll select it and I'll click on the workspace and I'll type 192.168.1.1. Okay, so we are going to use a network called 1.0/24, in which we are going to use 1.1 and we are going to use 1.2 over here. As you already must know that 1.0 cannot be assigned as an IP address. So we are just going to use this particular IP address with /24 subnet mask. And we will configure it by going on to the first device and then clicking on the static and typing down the IP address that will be 192.168.1.1. And then I can just press the tab button, and by clicking on the tab button it will automatically configure the the subnet mask over here. Make sense? And then I can close this particular window, and then I can go to the second PC, and then again go to desktop window, and then open up the IP config dialog box. And over here you will configure the second IP address, that is 192.168.1.2, and press the tab button. And then the subnet mask will automatically be configured. And you will be done, and you can close this window as well. So Packet Tracer also gives you a sneak peek of the configuration by just hovering your cursor onto the device. So you can just hover your cursor over there and you can actually see that it has two interfaces. One is fast Ethernet 0 and the other one is Bluetooth. The fast Ethernet 0 interface says that the link is up and the IP address that is configured on it is 192.168.1.4. Sorry, 1.1 and /24. And you can see that by hovering the cursor onto the second PC, you can actually see that the fast Ethernet 0 interface has the IP address 192.168.1.2/24. So can we say that they both are into the same network as of now? It's not taking any IP address automatically. We are typing that particular IP address statically. Fast Ethernet 0 is basically the name or the standard of the interface that is configured. On a very first day, we talked about the Ethernet standards that are there. Ethernet means 10 Mbps interface. Fast Ethernet means 100 Mbps interface. And then we basically have gigabit Ethernet and 10 gigabit Ethernet. So the speed kind of differs over there according to the standard that it is. So we are using fast Ethernet over here by default. It means that the port can send and receive data at 100 Mbps speed. Well, the gateway will be used later, okay, when we will try to implement routing and when the communication will be done, I would say between two or more different networks. Gateway is not needed as of now. It knows that we're configuring class C IP address because the first octet of the IP address is 192. Yes, the simulation works just like that it shows a MAC address as well. So it's assuming that it's having some, I would say, a virtual network interface card there. Subnet mask is already configured. You can see that over here it's 255.255.255.0. Again, the gateway doesn't need to be provided as we are not communicating between different networks. We are just in same network. Now we don't have to select any crossover or straight through cabling option. We will just be using automatically select like cable type by just using the first option that is available over here. Okay, now we will try and send message from first PC to second PC. And let's see how it works. So I'll just click on the first PC and then I will click on the second PC. Now, how do we do it? This is basically a normal packet that you can select. Okay, it's a simple PDU, packet data unit. And you can click on this and then you see that the message is selected. And then you can click from where you want to send the message. And then you can click on the destination where you want to send the message again. So you click over here and you can see that the message is sent and you can see the statistic over here that it's successfully delivered. Do you understand that? I will again do the option. So we select the message from here and then we click on the first PC and then you click on the second PC. And you see that it's again successfully delivered. The source is PC0, the destination is PC1. The type of the message is ICMP, which is Internet Control Message Protocol. That ping packet always send ICMP messages. The color will also randomly be selected, and other parameters doesn't really matter as of now. Do you understand that? How did we do the communication? ICMP is Internet Control Message Protocol. Ping packets basically use that. So whenever you want to send some traffic, it just sends demo traffic from one place to another place to check the reachability if it's available or not. Okay. Going deeper into the protocols is not part of our content as of now. So you can just have a look at Google if you want to clearly understand how ICMP works and all. Also, whenever you will install Packet Tracer on your computer, you can see that I'm being notified with the names of the interfaces that are here. That on the PC, the PC0, I'm using FA0 interface, and on PC1, I'm using FA0 as well. So this option might not be shown to you by default whenever you will newly install the Packet Tracer. And you can, what you need to do is you need to go to the edit option, and then you can go to preferences, or you can click Control R, and there will be an option that will be popped up to you. Okay, I'm using Mac, that's why I'll go to preference like this. But you will see that particular option in edit and preferences. Oh, sorry, edit and options. Or you can go to directly press Control R to get this window. And over here, from the interface window itself, you need to select always show port labels in logical workspace. If this is unchecked, then you can see that I will close this window. Now I don't see any interface names. So by default, it is like that. And in order to configure it, you can go to preferences, and then you can check this box that is always show port labels in logical workspace. So you can click on this and then close it, and you will start seeing the names of the interfaces that you're connected with. Do you understand that? So have you guys installed Packet Tracer on your computers? Okay. So try to do this particular lab, just a small lab. And as this is our Packet Tracer, so you can see that this was kind of the topology that we had. Now, in order to configure multiple, I would say, devices, I will, let's say, if I take now another couple of PCs, let's say I have this PC as well, and I have this PC as well, and I want this particular PC to again be part of the same network. So, and I want all of them to communicate together. The first one should communicate with second, third, and fourth, and second one should communicate with first, third, and fourth. Like that, everyone should be able to communicate with each other. So what can we do? We need to have a centralized device. And what device do we need? We can take a switch and connect all of these, I would say, computers together. You can just edit a node by just clicking on that. And this is how you can edit it. Cool. And now I will delete this directly connected link by clicking on the delete window, and then select this cable, and it is gone. And I can press the escape button when I'm done. And I will place the second PC over here, and I'll drag the node over here. And let's say that this is our PC number 3, and that's our PC number 4, and I will add a note to that as well, that this is going to have 1.3 as an IP address, and that's going to have 1.4 as an IP address. Cool. So I will connect all of these devices by taking a switch. So I will go to the networking device section, and I will go to the switches section. And from this switch section, I will take 2960 as the switch model. So I will drag this particular thing over here, and I will place it over here. Always select 2960 because it has enough number of ports that we will be using. Okay. And if you see the topology, you can just select all this topology and drag it over here to align it properly. And then what we are going to do is we are going to connect all of these PCs with the switch that we have. So we selected the cable again, and then click and click over here. Now we again need to select the cable. Now there is a shortcut that you can use. Okay, that whenever you are selecting anything from this window, if you want that particular thing for multiple times, you can just press your control button and then select the window and leave the control. Okay, and that's how you can select the cable. Again, I will repeat it. If you want the same utility again and again, you can, for multiple times, you can just press control button, then select the cable and leave the control button. And then you can go on and connect as many devices as you want without selecting it again, like this. Make sense? Like just like that, if you want multiple PCs, you will go to the end devices and then you will select this PCs by clicking the control by pressing the control button, then selecting PC and then leaving the control button, and then you can see one, two, three, four. Just click, 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 and you see that that's how it will work. Make sense? And if you want to delete all of that, you can select all of that and just click on the delete button, and that's gone. And then press the escape button. So that's how you do configure multiple devices, how you work. Good. And then we will configure IP addresses on these computers as well that do not have any IP addresses. As our first device has 192.168.1.1, the second one has 192.168.1.2, the third one doesn't have any IP address. You can see that it's not set. So I will go to the third device, go to desktop section, go to IP config, and say 192.168.1.3 over here, and then press the tab button. The cable is just automatically choose connection type, the first cable. Okay, always use that. If you want to remove the cable, then you can just select this delete utility. Okay, select this and then click on the link, and then that link will be deleted, and you can press the escape button again. And then if you want to connect it together, you can go into the connections and then select the first type of cable, that is automatically choose connection type, and then select it, connect it with this like that, and press the escape button. That's all. Makes sense? That's how you make the thing. And then you will, this is copper cable, man. Okay, it just automatically selects it that what based on the devices that you're using, whether it should be like straight through crossover according to auto MDAX. You don't need to select it from these devices. Okay, that will just confuse you. So just use this particular cable. Cool. And then I will go on to the third device and give it IP address that is 192.168.1.3. And then I will go on to the fourth device and go to desktop section and IP config and configure 192.168.1.5 tab and then close it. Makes sense? And then you can see that I can actually send packets from all of these devices. So I again, now whenever this window is full, you can just delete it by pressing the delete button and it's gone. Okay. Yeah, 1.4 is okay. 1.5, 1.4 doesn't matter as long as they are into same network. And then I will just click on the message and click from source to destination. Successful. I will send it from first to third PC. Successful. I will send it from second to fourth PC. Successful. You see that? That's how you do it. However, we haven't done any configuration onto switch yet. So I will do the entire thing again. Cool. I will delete everything. And then I will take a couple of PCs over here by going into the end devices section and then selecting, like clicking on the control button, selecting the PCs and placing 1, 2, 3, and 4 PCs. And then I will tag them with this tag button. And then I will say the first PC is going to have the IP address as 1.1, the second one is having 1.2, the third one is having 1.3, and the fourth one is having 1.4. And the network that we are going to use is 192.168.1.0/24. Good. And then you click on to the network devices and then click on switches. And then you drag 2960 over here and you place it. and then we basically connect them by going into the connections and selecting the first cable by pressing Control, select, and leave Control, and then click, 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 and click and click. That's how we connect them together. Then we will provide IP addresses on these devices. That's going to be click on the first PC, go to desktop, then select IP configuration, and then over here you can say 192.168.1.1 tab. Close it. The second one is going to be 192.168.1.2 tab. And then you can say go to the third one, say desktop IP config 192.168.1.3 tab, and go to the fourth one, desktop PC IP config 192.168.1.4 tab, and then close it. And that's what the basic configuration is. Then you can select messages from here. Okay, you click and select message, and then you click on the first PC and click on the second PC, and over here you can see that the message was successfully sent. Then you again select it, the message, then first to third, that's successful too. And then you can select first to fourth, and that is also successful. So that's how you make the communication possible between the devices by using a centralized device, that's a switch. I hope every one of you understands this basic lab that we did. Perfect. Now it's time to know some differences between these devices and how the switch actually forwards traffic. Okay, it's time to understand how the switching works. Okay, we call it as complete layer 2 network, because according to the OSI model, our layer 2 is data link layer. And at data link layer, the information that is added, that we come up with something called frame, correct? And frame contains source MAC address, plus it adds destination MAC address, plus it adds I would say it carries the other information of the above layers as well. But as MAC address details are added at layer 2 and the task is done by this switch, that's why switch is always called as layer 2 device, because it does its task at layer 2. However, there are some switches that works at layer 2 as well and layer 3 as well. We call them as multi-layer switch. But over here, we're just concerned about layer 2 device. Cool. So let's talk about how these devices works and what are the pros and cons of these devices in comparison with hubs. And so I will stop sharing my device, or I would say screen over here, and share my notepad screen. Perfect. So over here, let's see. If we connect, let's say, a hub, and with that hub, we connect a PC called A, then we connect a PC called B, we connect a PC called C, and we connect the PC called D. And the network that we will use is 192.168.1.0/24. And we say the IP address of A is 1.1, B is 1.2, C is 1.3, and D is 1.4. And then the MAC address of A is double A, B is double B, C is double C, and D is double D. That's what the MAC address is, just for assumption. And what's happening over here is A is sending some data from this A to D. So the source, can we say that the source is going to be A and destination is going to be D, meaning the source is going to be 1.1 and the destination is going to be 1.4, meaning the source is going to be double A and destination is going to be double B. And we can say that this information is layer 3 and this information is layer 2. Do you agree to this? Any questions? Oh, okay. The MAC address needs to be double D, right? So that's D and D. Sorry about that. Well, what I'm saying over here is these are the PCs that are there, right? We have attached four PCs, A, B, C, and D. And you can say that all of these PCs will, of course, have some IP address and will, of course, have some MAC address. So we are just assuming that the IP address of first PC is 1.1, the second one is 1.2, third one is 1.3, and fourth one is 1.4, just like the topology that we had. And every PC also has a MAC address that's double A, double V, double C, and double D. So when the traffic is going from A to D, we can say that the source is 1.1 with the MAC address double A, and the destination is going to be 1.4 with the MAC address double D. Do you understand that? Now, what's going to happen is as the IP addresses are added at network layer, that's why we say that this is layer 3 information and this is layer 2 information, as MAC addresses works at layer 2 and IP works at layer 3. Now, the communication is going to happen from this particular PCA, and the message will first go to the hub, as this is what the cable is connected with, correct? Between PCA and between the hub. So let's name the interfaces of hub as Ethernet 1, Ethernet 2, Ethernet 3, and Ethernet 4. These are the interfaces that the hub is connected with. And then you can say that what's going to happen over here, the communication is going to be done from A to D. So whenever I initiate the communication, the OSI model will kind of grab all the information that it needs for sending out that particular traffic, and then the traffic will be reached out onto the hub. Now, what type of communication is it? We discussed about the type of communications that you can have, and we had the type of communication as unicast, we had type of communication as multicast, and we had the third type of communication as broadcast. Correct? What type of communication is it? Does it needs to be a unicast, as the message going from specific host to specific destination from A to D, right? And it needs to be unicast. But when we talk about hub, then hub's characteristics say that it can only send broadcast traffic. Cool. And most of the people are guessing in the chat section that hub is considered as dumb device and it's not intelligent enough to forward, I would say, unicast traffic or multicast traffic. But there is as well a logic behind that. Cool. It's not like that hub is like a dumb device and there's no logic. It's not any rocket science. What happens is whenever the device is sending some traffic from this A to D, the traffic is being received at hub, correct? And when the hub will receive that traffic, hub needs to configure, or hub needs to consider the information that what is the source IP address and what is the destination IP address. Apart from that, it will check what is the source MAC address and what is the destination MAC address. Correct? If anyone directly comes into your home, would you let that particular person like come into your home? No, of course not, right? You will first ask that particular person, or you will kind of see whether do you know that particular person or not. Make sense? Just like that, whenever this hub is receiving that data from A, then hub checks, okay, that this particular device is connected with me. But hub doesn't have any brains to process such information, which is source MAC, destination MAC, source IP, and destination IP. That's why what hub believes is as I have received some information from PCA on Ethernet 1, what I need to do is I need to forward that particular traffic on all the ports, and we call it as best effort forward, meaning that switch will just forward that particular traffic to each and every port that is available except the port that the data was received on. Do you understand that? Because it doesn't have any brains to maintain some information that how to reach out to D or C or B or A. It doesn't have any information about that. That's why whenever there is traffic that's coming onto this line, it just forwards the traffic on all the interfaces except the interface that it received the traffic on. And that's why it is called as a dumb device. Yes, hub can only forward broadcast traffic. It cannot forward unicast traffic and it cannot send multicast traffic as well. It can only send broadcast traffic. Good. Also, there is another thing called it works, okay, and it works on half duplex and doesn't work on full duplex. Now, what does this half duplex means? Assume that if you see whenever there is a classroom, let's say, and in that classroom there are 10 people. So let's say in this particular classroom you have 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10, and then there is teacher as well that stands at 11, and then there is a gate. Correct, this is nothing but a door. Now, can you say that what will happen if I ask each and everyone to stand up and take an exit from that particular door? What would happen? Can I say that in this scenario, if I design something like this, you have 1, 2, 3, 4, and 5, 6, 7, 8, 9, and 10, and then there is a gate, which is a door. And if I ask everyone to stand up and like get out of the class, we can say that the scenario that will happen is called as collision. Make sense? Just like that, whenever you send traffic from here, okay, that needs to go over here, and at the same time it's possible that the hub will receive the traffic from PCC as well or PCB as well. And what will happen? It There will be data collision. And how will a hub respond to that data collision? It will respond to it by sending out jam signals. It will announce that the lines are jam. Do you understand that? And it will also include some timer with it, like let's say 5 seconds, and then it will say 7 seconds and 10 seconds. It just sends random times, okay, with that jam signals. Do you understand that? That how collision works, okay, and how hub only works on half duplex. So due to this nature of hub, what it does is whenever there is any, I would say, data traffic that is being initiated from multiple links, it uses a technology called CSMA CD, which stands for Carrier Sense Multiple Access Collision Detection. And what does Career Sense Multiple Action Collision Detection does, or CSMACD does? It just kind of, I would say, senses, or according to the topology that you have seen, let's say, round topology, okay, or round robin topology. What happens, or you could say token ring topology. By using topologies that comes according to the standards of CSMACD, there will be a token that will be passed. So the A will have the token first, and it will then send the data. When it's done, the token will be passed to, I would say, let's say B, and then B will send the traffic. And when it's done, it will pass the token to C, and C will send the traffic, and then it will send the traffic to D, or send the token to D, and D will send the traffic. And the process just repeats again and again. Do you understand that? That's how hub kind of avoids letting collision domains overtake the network that it's connected with. Also, there is one more thing that we talked about is there is something called collision domain and broadcast domain. Collision domain and broadcast domain. So what does collision domain mean? As I told you the same example that if all these 10 people stand up and go out of this particular device, okay, or the use that particular door to go out, what will happen? There will be collision. But what happens if I just create each and every single door to for all the people that are there? So let's say there is door number one, door number two, three, four, and five, and then six and seven and eight, nine and 10. So one will take an exit from that dedicated door, two will take an exit from that, three will take the exit from its own door. Will there be any collision that will ever happen? There will of course not be any collision, right? But as hub doesn't provide this particular feature, as it only works on half duplex, okay, just because of that, I would say that the hub only has one collision domain, which means it just has one exit door for all the traffic that it can send. Good. That's how it works. So hub only has one collision domain and one broadcast domain. We can say that when one person is talking, it just says that listen to that particular person, and then everyone listens to that and doesn't send any data over there. Cool. That's how it works over here. So whenever I say that if I give you a topology like this, how many collisions domains do you have? Just one, which means that it just has one exit door and one entry door that works on half duplex, which means you can either send a data at one time or you can receive that particular data at one time. So that's what we call it as half duplex. Do you understand that? And because of all these issues that Hub had, we do not use hubs anymore in our production environments. And we only use switches in order to connect multiple endpoints together. And how does switch benefit us? We kind of change this particular thing to switch. Okay, and how does switch benefit you from that? Switch can, I would say, send traffic. I will just clear these things. So switch can send unicast, it can send multicast, and it can send broadcast as well. Do you get that? It can send all these traffics because switch mentions something, and hub is not a dumb device anymore. It is kind of a smart device because it maintains something called MAC address table. So I will just take this information over here. I would say that switch kind of maintains something called MAC address table. Means that it keeps track of how many ports does it have and what are the MAC addresses that are configured on that particular port. So let's say that it has Ethernet 1, Ethernet 2, Ethernet 3, and Ethernet 4. So it will have a database that Ethernet 1 has a MAC address that is connected as double A. And then Ethernet 2 has a MAC address called double B. Ethernet 3 has a MAC address of double C. And Ethernet 4 has a MAC address of double D. Do you see that? So whenever the traffic is coming from A that needs to go to D, the switch, whenever that receives the frame, it opens that up and it checks that, okay, it's coming from Ethernet 1. So do I know that particular person? It says, yes, Ethernet 1 is connected to double A. Cool. And then it checks that the destination information is double D there. So it again checks into MAC address table that do I know anyone called double D? And it says, yeah, it knows about double D and that is connected on Ethernet number 4. So what switch does? Switch just sees that information and it forwards that particular traffic onto Ethernet number 4. That's how this particular communication works. Also, as hub used to work on half duplex, switch doesn't work on half duplex. Switch works on full duplex, which means that if you are connected to an Ethernet port, it can send and receive traffic at the same time, okay, on each and every interface that it has. Good. And then, if we talk about the collision domain and broadcast domain, then the example that I give you of having multiple people over here, and for everyone 1 2 3 4 5 6 7 8 9 10, you can say that each and every person is going to have its own exit and entry point. So that's why you can say if a switch has 24 ports, then the switch will also have 24 collision domain. Makes sense, so that the data doesn't ever, I would say, collide with each other. Okay, and MAC addresses are stored into something called MAC table, but MAC table is also called as CAM table, and CAM stands for content addressable memory. Are we good? So that's why, or that's how collision domains and broadcast domains differ with each other. I hope you understand that particular information. Then we will move ahead with some extra information as well about switch. Okay. Let's say that a switch is there. So pay your attention as we are going to talk about how a switch learns about the information. So we have a switch, the same topology that I'll take, in which you have a user A, then a user B, a user C, and we have D as well. And let's say the IP addresses that we were having was 1.1, 1.2, 1.3, and 1.4. And the MAC addresses were double A, double B, double C, and double D. Cool, these are going to be the MAC addresses. Now, assuming that the message needs to go from here all the way to upwards. That's what the communication is going to be. So switch A first is going to receive a message, right? And whenever switch A receives the message, it inspects the frame that it's receiving, and in the frame, it's gonna see that source MAC address is double A. It's not going to see the IP address because it doesn't have any understanding regarding the IP address. And let's consider that the switch has recently been started. Okay, so it doesn't know any information about who are its endpoints that it's connected with. So we can say that the MAC address table is almost empty. If we talk about it, then the interface has no details and the MAC address has no details as well. And that's our MAC table. It good. So when it learns about it, then the it says and inspects the frame that the source MAC address is double A and destination MAC address is double B. So sorry, destination MAC address is double D. Now understand one thing, that switch, there is a terminology that you need to understand, and that's a note that switch only trusts on source MAC address and it doesn't trust on the information that you will give it on the in the field of destination MAC address. Is it clear to you guys? Switch only will trust onto the information that is mentioned into the field of source MAC address, and it will not trust in the information that is there into the destination MAC address. So, as soon as switch receives the first packet, what it does, it just makes an entry into its MAC address table that there is a guy who is connected with me, with which is connected on, let's say, F0/1, and this is F0/2, this is F0/3, and that's F0/4. So it makes an entry in its MAC address table that with F0/1, I'm having a user called double A. Good. And then it just checks that it needs to go to double D. Then it comes back and looks into its MAC address table that do I know anyone that has a MAC address double D? It says there is no one, correct? So what will it do? It is going to forward, it is going to do a task of something called flooding. And what is flooding? Flooding means forwarding a copy of the frame on every interface except the interface that the original frame is received on. Do you understand that? Flooding means that forwarding a copy of the frame on every interface except the interface that the frame came on. So again, flooding means forwarding a copy of the frame on every interface. Okay, the I would say on every interface that the original frame is received on. Okay, so I would say that the frame is received on FA0/0. So it's gonna flood that particular message on FA to 0/2, 0/3, and 0/4. And it will flood that particular information, okay, so that it will what does it do in the flooding message? It says that, hey there, is there anyone who is having the destination MAC address as double D? Do you understand that? So a copy kind of indicates that the users who are connected with it needs to notify to the switch if they have the destination MAC address inside of their as compared as their as configured as their MAC address. So what's going to happen? The D will forward a reply to that, right? That, hey switch, I am having the destination MAC address as double D. And when D is going to send that acknowledgement, the acknowledgement will contain the source MAC address as I would say double D, correct? And the destination MAC address will be the base MAC address of the switch. Apart from like switch also has a base MAC address, so it's gonna be the same thing. So switch is going to forward that particular traffic on each and everything, on each and every port that's there. Good. And then as the information of double D is mentioned into the source MAC address field, I would say that switch will store the same information into its MAC address table and it will say FA0/4 is connected to double D. Do you understand that? And this is how switch kind of learns MAC addresses and builds its MAC address table. This is done for the first time only, yes. But you need to understand that switch the MAC address, like switch only stores the MAC address of a specific host for 300 seconds. So MAC age time is 300 seconds. And after every 300 seconds, it just recommunicates with the device as there are multiple packets that flows through. So switch kind of relearns about the MAC addresses that are connected with it. And it's all the process that happens inside of a switch. So you don't need to worry about it. But you need to know that switch can only store the MAC address for 300 seconds. And we're talking about dynamically learned MAC addresses over here. Makes sense. That's exactly how switch learns this MAC address. And once it knows about the destination MAC address in its MAC address table, then the switch is going to forward the traffic onto FA0/4. And that's going to be a unicast. Do you understand that? That's how unicast actually works on switch. Now, whenever the switch is going to receive these frames that the switch doesn't know the IP address about, or that the switch doesn't know the destination MAC about, uh, we talked about the operation of flooding. But whenever this flooding is happening to get to know about the destination MAC address, We call this flooding as unknown unicast flooding. Do you get it? What's unknown unicast flooding? What's unknown unicast? Unknown unicast are the frames that are basically, I would say, the frames about which the MAC address is not stored into the MAC table. Those will be called as unknown unicast because they are unknown to switch. And whenever switch does the flooding of the frames to get to know about the destination MAC address, we call these as unknown unicast flooding. The process is called as unknown unicast flooding. Now the switch does forward these traffic onto each and every port without considering the source MAC and destination MAC and the source IP and destination IP. There is also a thing as compared to flooding called broadcasting. These are not broadcast. Okay, flooding and unknown unicast flooding is not called broadcast. We will call it a broadcast whenever the destination MAC address is filled up with the information of double F, double F, double F, double F, double F, double F, the last MAC address. Whenever the destination MAC has this particular MAC address as double F, double F, double F, and everything will be F, then we call it as broadcast message. And that broadcast message will be forwarded on each and every port. Do you see that information? Do you understand that how it works? Well, flooding is basically something that to get to know about or to build the MAC address table. Broadcasting is forwarding that particular traffic on every port with intention. Whenever you do flooding, the endpoints doesn't accept the original frame. They will only accept the frame if they are the receivers, the original receivers or the dedicated receivers. But in broadcast, everybody that is connected with the switch will accept the frame. You understand now what's the difference between flooding and I would say broadcast? Okay, now we will see this particular thing, the MAC address table, inside the switch as well. So I will stop sharing this particular screen and go back to my laptop. That over here. So what I'll do, I'll just try to delete this particular switch and have a new switch with us that doesn't have any data that we have forwarded. So I'll take this particular switch over here and connect these devices with it. Here to here, here to here, here to here, and here to here. Cool. Now I will go to the command line interface. Now we have not had our introduction to command line interface and iOS and all. Okay, so just ignore that part as we are going to discuss about that tomorrow. So I'll just open this particular thing up and I will go to the command line interface and I will show you how does the MAC address looks like. MAC address table looks like. And ignore about the commands that we are using or so. We are going to practice the same thing. So I'll go to the enable mode, conf t, sorry, and I will see, I will use a command that says show MAC hyphen address table. And when I see that, you see, there is no information called MAC address and ports. Nothing is there. Cool. So what I'll do now, I will send a traffic from this PC to this PC. And as I send it, you see that the last message is successful. And then I will go back on my switch and check the MAC address table. And you see that it learned about the first PC that is connected to FA0 and the second PC that it's connected to FA0/2. Also, it still doesn't have any information about 3 and 4. So when I forward traffic from 3 to 4, it's again successful. And then I go back on my switch and and again see the information. The information is 3 and 4. And when I forward traffic from here to here, it's successful again. And it's 1, 4, and 3. Okay, so that's exactly how it basically builds up the MAC address table and send the traffic to each and every one. And then check the MAC address table. And it has the details about all the 4 I would say PCs that are connected with it, along with the MAC address and the port information and the VLAN ID. So you can ignore the information that's there. But as we are going to talk about VLANs and how does these dynamic and I would say static MAC addresses work, that's not really dynamic and static is not really part of your content. But yeah, we will discuss that. Okay, as it's necessary. But the only thing that you need to see is understand how switch actually works over here. It's not multicasting yet. The multicasting is altogether a different thing. Don't confuse yourself. Just use specific things that it's unknown unicast flooding, not a multicast. If PC doesn't send packets, then switch will not know about it. But by default, there are communication that are done, like ARP communication and all. And switch anyhow just gets to know about the user that is connected with. Otherwise, it's kind of would be a security issue also. 300-second range is basically when this particular switch, if there is no communication from these MAC address, then switch will kind of forget about the MAC addresses that have been learned in 300 seconds. But usually in production environment, there will of course be some communication that will be done in 300 seconds, and the counter just restarts from 0 to again 300 seconds. So if let's say that it has been 120 seconds that the switch has learned about this MAC address, and then there is another new packet or new frame that comes up from the same MAC. So the counter again like resets to 0 and again starts for 300. You see that? So most of the time it never like expires. Makes sense to you? Understand? So you can try this as well in your packet tracer. Broadcast is done on switch whenever you forward a traffic, having the destination MAC address as all Fs. However, it's not over here. The packet tracer is not that advanced that we can do advanced stuff over here. So we'll just use it for basic things, implementing switching and routing and doing some security stuff and all. Okay, so don't be curious about that. So yeah, that was the content that we had to discuss today. I hope you found it interesting enough. Okay, where we got to know about switching and how you can build up your topology in packet tracer and how you can send traffic from one device to other device. Unknown unicast spreading again doesn't use any source or destination. It just forwards the traffic onto the line. So that's kind of a layer one transfer. It doesn't send the original frame. It just sends the copy of that particular frame. Cool. So yeah, thank you. That was it. I would say for the day, where we discussed about the basic operations of switching. Perfect. Thank you. Thank you so much for tuning in today. Okay, I hope the class was good enough and you understood it. And I try to keep it as simple as I can to make you understand how switching works. So thank you so much for tuning in. Take care of yourself. Okay, I'll see you guys